Hi guys, for this next video, we will discuss series connected resistors. I'll demonstrate how to calculate for its total resistance, current flowing to the circuit, voltage across each of the resistors, how much power is absorbed by the two resistors and how much power is delivered by the source. Consider this circuit guys, 20-volt source connected to two resistors in series. R1 and R2 with a value of 10 and 15 ohms respectively. The total resistance, RT, of series-connected resistors is calculated by adding the individual resistances, R1, R2, R3, and so on. So the R total in this given circuit is equal to R1 plus R2. Using the values 10 plus 15. And it's gonna be 25 ohms. In solving the current flowing in this series circuit labeled as IT, it is equal to voltage source VT over total resistance RT. Substituting the values 20 over 25. This will result in 0.8 amperes. Next is to solve the voltage drop across each of the resistors. Remember that voltage V is equal to I times R. And remember that in series connection, current is equal all throughout the circuit. So VR1, the voltage across R1, is equal to IT times R1. Using the values, 0.8 times 10. Then it's gonna be 8 volts. Then the VR2, it is equal to IT times R2. 0.8 times 15. That will be 12 volts. In series circuit guys, the sum of all voltage across each resistor should be equal to the voltage source. In formula, VT is equal to VR1 plus VR2 plus VR3 and so on. To check if your voltages across resistors are correct, just add VR1 plus VR2. 8 plus 12 is equal to 20 volts. Meaning these are correct. Next is to calculate for power absorbed by each of the resistors. The power at R1 will be labeled as P1 and at R2, it will be P2. The formula of power is V times I. So P1 is equal to VR1 times IT. VR1 is 8 volts, so 8 times total current 0.8. It will be 6.4 watts. Then P2 is equal to VR2 times IT. 12 times 0.8. The answer is 9.6 watts. Then to check if these are correct, we are going to solve for total power delivered by the source and it should be equal to the summation of all the power absorbed by all the resistors. PT, the total power delivered, is equal to VT times IT. 20 times 0.8 and it is equal to 16 watts. Add P1 and P2. 6.4 plus 9.6 watts and also it is equal to 16 watts. Meaning we are correct. In formula, PT is equal to P1 plus P2 plus P3 and so on. We go now to our next example, a voltage source connected to three resistors in series, labeled as R1, R2 and R3. The values of resistors and the voltage source are given. So now, we have to compute the total resistance RT, which is equal to R1 plus R2 plus R3. We have 6 plus 10 plus 15. which is equal to 31 ohms. Then for the total current IT, it will be VT over RT. Substituting the values, 50 divided by 31. That will be 1.61 amperes. Then next we will solve for the voltage across the three resistors, VR1, VR2 and VR3. To solve for the voltage drops V, it is equal to I multiplied by R. VR1, it is total current IT, times R1. Total current is 1.61 multiplied by 6. It will be 9.66 volts. VR2 is equal to IT times R2. Using the values, 1.61 multiplied by 10. So the answer is 16.1 volts. Then, lastly for VR3, it is equal to IT multiplied by R3. So, 1.61 multiplied by 15. Then the result is 24.15 volts. Then we have to check if our answers are correct. The sum of VR1, VR2 and VR3 is equal to 9.66 plus 16.1 plus 24.15. It is approximately 50 volts. Meaning our answers are correct. Now we are going to solve for the power absorbed by each of the resistors. P1 is equal to VR1 multiplied by IT. VR1 is 9.66 times total current 1.61. Then the answer is 15.55 watts. P2 is equal to VR2 multiplied by IT. 16.1 multiplied by 1.61. It will be 25.92 watts. Then for P3, it is equal to VR3 times IT. 24.15 times 1.61. This will be 38.88 watts. Then we will also compute the total power delivered by the source, PT. PT is equal to voltage source VT, multiplied by total current IT. 50 times 1.61. It will result in approximately 80 watts. Then to check if our answers are correct, the summation of the power absorbed by each of the resistors is equal to total power PT. The summation of P1, P2 and P3 is equal to 15.55 plus 25.92 plus 38.88. This will be approximately 80 watts. Meaning our answer is correct. So that's it guys, that is how we solve series circuits. Thanks for watching. If you enjoyed learning about series circuits, give this video a thumbs up. Don't forget to subscribe and hit the bell to stay updated on more easy to understand tech content. Questions or comments? Drop them below. Keep exploring, stay curious, and see you in the next video.